thank you very much to the Greater London Authority for their presentation before us about consolidating planning data in London into a set of maps, services and data. So carrying on that theme, for the next 20 minutes or so, Ajey and I are going to take a step back and discuss the options for opening up your data silos with ArcGIS Web Services. We'll talk about the options for automating the ingestion, analysis, and integration of data in the ArcGIS system. So it's well understood that the quality of your analysis in GIS, and subsequently the decisions you can make, are only as good as the quality of your foundation data sets. Therefore, it's really important to develop workflows that ensure and maintain data quality at the point of entry in your GIS. And with that comes challenges about how all this data is managed. Just like we might consider the spatial resolution, we need to think about the level of detail in things like data versioning, metadata, and naming conventions. And with that in place, ArcGIS Web Services can act as the single source of the truth for your data. That means you and your users can be sure they're editing and viewing the right layers and doing so simultaneously. And lastly, it's worth noting that web services aren't always the last stop on the journey for your data. So it's important that data sets you publish to ArcGIS are interoperable and can be used in other systems. So how can we be cognizant of this and improve our data workflows? Well, Ajey and I will take you through a few of the common ways you can integrate your data via ArcGIS Web Services. We'll start in an online environment with some fairly simple examples and then add in some complexity as we go. So starting with ArcGIS Online, there's a number of options available to create automated data workflows. One way we can break this down is to think about the flow of data in three parts. So ingesting data, analyzing, enriching data, and then exporting or integrating data in other systems. So starting with ingestion, we have drag and drop tools for automating this, such as ArcGIS data pipelines, which is useful for data that doesn't update as frequently, and Velocity, which you can use to ingest real-time data feeds. And you can also access the functionality and extend this using the Python API and ArcGIS notebooks. And then the next step, analysis and enrichment. And ArcGIS Online comes loaded with applications, analysis tools, and data to analyze and enrich this web service. And similarly, you can automate a lot of this using the Python API in a notebook. And lastly, any web services you publish to ArcGIS Online can be consumed in an open format, whether that's via a REST API call, via an OGC format such as Web Feature Service, Web Map Tile Service, or through a file download in ArcGIS Hub. So I hope that was a useful background to using web services and online. We'll stay on this theme and move into a deeper dive into data pipelines. So ArcGIS Data Pipelines is a relatively new data integration capability of ArcGIS Online that we first brought in June last year. And they allow you to connect to external data sources and convert them to web services with a set of tools to clean, construct, integrate, and format your data. This sort of functionality has been available through developer technology for quite a while, through things like notebooks and Python, but that's required a level of proficiency in writing code. So Pipelines brings all of this together in a drag and drop interface, making the process of preparing and integrating data in online a bit quicker and easier. So let's contextualize this. Imagine you want to publish a CSV containing local authority level data, which is by its nature not in a spatial format. And the end goal is to bring this data to life in a web map. You could import the data and perform some pre-processing, then join that data to a spatial boundaries layer, for the local authority boundaries layer, and you can do all of that in one place with ArcGIS data pipelines. And traditionally, a lot of this was achieved through desktop tools such as Model Builder and data interoperability. So one of the real benefits is that Pipelines is available to all ArcGIS Online customers, including those users who don't have access to the desktop tools. So what can you do with pipelines? I've already mentioned you could bring in CSV files, but there's a lot more you can do. So you can bring in hosted data from your portal or data that's shared publicly that's accessible via a URL. You can connect to datasets in external stores such as Amazon S3, Microsoft Azure Storage, and cloud data warehouses such as Google BigQuery and Snowflake. And there's a set of tools to filter and clean your data, to calculate new fields, and there's also a native arcade editor built in. New as of November last year, you can now schedule pipelines to run as automatic tasks, for example, as and when your data updates at regular intervals. So here is ArcGIS data pipelines opened in an editing session. And this view might be familiar to those of you who've used Model Builder in ArcGIS Desktop, in that you can drag and drop data and tools into a flow diagram. Let's start with the input data. For this demonstration, I'm starting with a tabular data set hosted in an Azure storage container, showing the number of houses that were started to be built in England in 2022. I've got access to the local authority name and code, as well as the number of houses built by their tenure type. I've also brought in a local authority boundary data set from the ONS, which is hosted in the Living Atlas. And I've used the filter by attribute tool to filter this data set to the extent of England. So back to the house building layer, I'd like to make sure all of the fields are formatted correctly. And in this example, I've used the update fields tool to set all of the numerical fields to integer types. And now that I've performed that pre-processing, it's time to join those two layers together using the join tool. I can use that local authority code as the common identifier between both the data sets. And finally, I've set this pipeline up to replace an existing layer in my content, and as the data updates quarterly, I've set up a scheduled task to run every few months. So moving to the map viewer, we can visualize this house building data per local authority using pie chart symbology. And the size of the pie chart indicates the total number of house building starts, and then the discrete colors symbolize the tenure type. For example, it's now really easy to visualize the spatial distribution of house building across the London boroughs. So in a few simple steps, we've transformed a tabular data set to a powerful visualization with a process that we can run automatically as and when the data updates. So we've seen data pipelines in action, but let's now talk about the practical considerations. Well, first of all, the good news is that any creator, user, or above can get started with pipelines as long as they have the privilege enabled in their user role in ArcGIS Online. Something to be aware of is that the usage of data pipelines is charged in credits per minute, similarly to advanced notebooks if you've used those. They use 50 credits per hour when editing and 70 credits per hour when running a scheduled pipeline. But overall, they're relatively easy for most users to pick up compared to some of the other approaches to data integration. And you also have the ability to share pipelines between your users in your ArcGIS Online portal. So in essence, data pipelines are great for cleaning and integrating data in the ArcGIS system in an automated way. But what if you need to add in some additional analysis or business logic? Well, that's where notebooks really come into their own. And with that in mind, I'll hand over to Ajey, who will show us more.
Thank you, James. So let's look at a scenario in which you need to analyze data further, merge information from several layers, and manipulate it based on spatial location. ArcGIS Notebooks provides a Jupyter Notebook experience within ArcGIS Online to address your analysis, automation, and visualization needs. ArcGIS Notebooks offers a set of powerful spatial Python libraries like the ArcGIS API for Python and ArcPy. And it also offers several open source data science libraries. So there are two runtimes that you can choose from: the standard runtime, which includes ArcGIS API for Python, and the advanced runtime, which includes ArcPy, in addition to the several other data science libraries available. So the Living Atlas of the World offers a wide variety of geographic information from around the world that you can add to your analysis workflows. You can easily add these layers with the click of a button in your notebook. Once you have completed your analysis, you can schedule them as tasks within notebooks. So now let's consider a scenario where the house building hosted feature layer that James created using data pipelines needs to be enhanced further to include demographic information like population. Content from the Living Atlas can be used to enrich data in ArcGIS notebooks using ArcGIS API for Python. So here in this notebook, I'm going to show you how to enrich data that James showed earlier. Before we take a look into the demo, let's take a look at the user interface that ArcGIS Notebook offers. As I mentioned earlier, ArcGIS Notebooks offers a Jupyter Notebook experience within ArcGIS Online. This means you can access ArcGIS Notebooks by clicking the Notebook tab in ArcGIS Online. So in addition to the Jupyter Notebook experience, we also have few buttons. The Add Data button, which is used to add content from ArcGIS Online. So we also have the Analysis tab, where we can insert analysis tools inside your notebook. You can create code snippets. You can add them into the notebook for your analysis. We also have tasks that can be scheduled to run later in a point of time. So to start any analysis, the first step is to import all necessary libraries. So here I'm importing a set of ArcGIS API for Python libraries to do my analysis. So as you can see, when I click on Run, so I'm prompted with a warning message saying that I have been logged in with an administrator role. So logging in with an administrator role lets you do some ArcGIS Online administration tasks as well. So the next step in running this notebook is to add item into the notebook for analysis. So for doing that, we can make use of the Add button. So here I'm selecting a group where data shared by James is shared with me. So when I click on Add, it inserts this into a cell. So when I run this cell, we can see that this layer is available within the notebook for us to use. So the next step is to enrich this content from using content from the Living Atlas. So I'm going to use the enrich tool to do that. For this, I've already created a code snippet, which I'm going to add now. This is very similar to the way we add items into the notebook. And when this is being run, so content from the Living Atlas is used to enrich this data. So we have used population information from the Living Atlas. We can also see that there is a small cost element to this. So more information of cost of credit consumption can be found in ArcGIS Online Help. So the next step is to enrich, view this enrich map. So that can be done by using this code snippet. So as you can see here, content has been enriched with the population information. But not all our workflows originate from ArcGIS Online. There may be instances where we need to use a desktop application like ArcGIS Pro. So now let's delve into some of the options that we have within ArcGIS Pro. Starting with Model Builder. Model Builder lets you create a reusable geoprocessing model by chaining up multiple geoprocessing tasks together. You can do it through a graphical user interface that Model Builder offers. When our analysis requires more sophisticated custom business logics to be implemented, we can make use of ArcPy. ArcPy offers all the geoprocessing tools that Model Builder offers. In addition to that, you also have few libraries like the data access module for low-level access for making any manipulations. You can also go a step further by creating a script tool which can be shared with your colleagues. You can create this script tool by embedding the code that you created and also exposing parameters. We also have tasks which can be used to guide the users through a particular workflow. So this is best preferred option when handover times are limited and you want to make sure that best practice workflows follow. Now let's look at a real-world example of where utilizing Model Builder or ArcPy is imperative. Ordnance Survey releases its address-based premium data in epochs of 6 weeks. The pre-processed OS premium data released in every epoch is a collection of CSV files. I need to flatten these set of CSV files and create a single point feature class and share it as a service. If the use case is fairly simple, like merging these CSV files into one flattened table, you can make use of Model Builder to do that. But let's say the required table needs to have values from CSV files combined into one with a business logic, like creating a single line address information, which involves pulling data from various fields in different CSV files that we have. So you can make use of ArcGIS to do that. You can also script the process of publishing this into ArcGIS Online using ArcGIS. To wrap things up on ingestion analysis and enrichment options, we have data pipelines, which help you build easy to configure ingestion workflows with limited options for analysis. ArcGIS Notebooks offers access to ArcGIS API for Python and ArcGIS to ingest and analyze content. Model Builder is a desktop option that we have to chain geoprocessing tasks together. And finally, we can make use of ArcGIS for implementing custom business logics in ArcGIS desktop. So with that being said, James is going to talk about options to integrate and export web services. Over to you, James.
Thank you, Ajay. So we've explored some of the common ways to integrate data into ArcGIS web services, but what next? Well, like I mentioned before, all the services you publish to ArcGIS are accessible via a REST API. So not only can you plug this into other ArcGIS applications, but you could also make queries from third-party applications. For example, making a query from a CRM system to find the local authority who built the most houses last year, or to perform a query to return that same boundary in a spatial format. And alongside that, any hosted feature services or tile layers in your ArcGIS Online or ArcGIS organization can be consumed as WFS or WMTS services, as long as you enable that capability in the item details. And let's not forget ArcGIS Hub, which is also a great way to share maps and data internally or externally. If you've not seen it already, a good example of this is the Met Office Climate Data Portal. And another nice example is the Office for National Statistics Open Geography Portal, where you can find local authority boundaries that were used earlier amongst thousands of other data sets. And as well as web services, Hub also offers the option of downloading that data in a commonly used format such as shapefile, GeoJSON, and file geodatabase. So just before we finish, I wanted to leave you with a useful new resource center that we've made available called the ArcGIS Architecture Center. And this is a fantastic set of documentation for GIS and IT professionals focused on architecting and designing good GIS and data workflows. In particular, I want to highlight the integration approaches and methods page, which talks about many different ways to approach data integration and goes into far more detail than we've had time for today. So all there is left to say is thank you. If you have any questions, please come and find Ajay and I afterwards, and enjoy the rest of your day. Thank you very much.